Hey guys, welcome to the next video on time series. In this video, we will learn about autoregressive model in R. So I'll just write down the purpose of these kind of models. They actually believe that the past variable has an influence on the upcoming value in the future of a variable. So if I have to write down the purpose, it's basically relating time series variable. So what can be a time series variable? It could be GDP also. It could be public debt. It could be any variable which is occurring over time, like in period 1, period 2, period 3, and getting its influence from the past value. That is what autoregressive model. It basically relates the time series variable to its past value. In this video, we are going to see how they are actually estimated, and then we will also take an example of forecasting GDP with the values available in the past. So if I have to write down how exactly it looks like, it will be yt. So that would be a dependent variable in time period t, and there would be an intercept. After that, there would be a coefficient of past value, and then there would be residuals. So in this case, yt minus 1 is your dependent variable value in the past year, and the whole of this equation, since it has only t minus 1, that is only one period, we call it first order auto regressive model. So the way it is written in statistics is like this: auto regressive to value 1. Now if I put 2 here, it will be AR2. So it will be auto regressive model, and there will be 2 periods lag. So the value will go from period t to t minus 1 to t minus 2. So t minus 2 value will be put in this equation in that case. Okay. The next thing is, how can we calculate first order autoregressive model of GDP growth if I have to? So the example we are going to take in this video. So in order to calculate GDP growth in period T, what I have to do is I have to write GDP growth rate. That would be my equation. And because this would be estimated, so I have to put hat here. The next thing would be your intercept, and then your coefficient. And what I have to do here, I have to take GDP growth in period t minus 1. In this case, I am not going to add the residuals because I am already having predicted value here. If I add here the residual, it will become non-predicted value, that is the actual value. Okay. So what we are going to do now is we are going to create this kind of equation in R, and then see what would be the coefficient and what would be our value for forecast. So we will forecast here, and with this we will start working on the data set we have in R. All right, so let's move to the data set, and I'll just hide this, and after that we will come back to this equation and see what exactly the value of B0 and B1 for us. All right, so next what we will do, we will start with R, and in R I'm going to start with the required libraries. I will say library AER, and then I'll say library quant mode, library read Excel, and next would be library forecast. Okay, so I'll just increase the size for you. Yeah, and we have installed all the necessary libraries. So libraries AER is used for your econometric analysis. Then library quant mode is used for financial quantitative modeling, and read Excel is used for reading Excel files. And then we have the libraries forecasting, because we want to forecast the value of period T using the data in period T minus 1. Next, what I'm going to do is I'm going to upload the macroeconomic quarterly data, which we used in the first video also. So I'll just write down US macro data, and then I'll write read underscore Excel X file, and now I have to give the copy part. So I'll go here and I'll just press shift and right click on it, and I'll copy as path. Also, I'll look into the data set. How does it look like? So if you see here, I have around 9 here, and then I don't have the value for the first column, and if I look through it, it is on sheet 1. All right, so I have all the necessary details with me. Now what I'm going to do is I am going to go back to R and copy paste whatever I had. I'll just put forward slashes here, so that this is the way reads through the data set. Now I will just mention my data set is on sheet 1, and I'll also say that my column types is, because the first one was in date, so I'll say text, as well as I have my data set repeated numeric, and then I had 9 there. So okay, all right. So now what I'll do, I will run this data set, and it has read my data set. Now I will convert the data column to years quarter, like the way we did in our first video. So I'll just write US macro data, the name of the data set, and then I had it. Basically, this is the name I had for my first column, so I'll write that one. And I want it to be quarter wise, so I'll write as the quarter, and I want it to be quarter wise, so I'll write as dot year quarter, and then I'll write the name of the variable, and then I'll give the format also. So I'll just run the required, and we covered this in our first video also, because we had to name the first column. I'm just writing the same. So after this, you'll understand how exactly we work with the macro variables dataset. Yeah. So, and next what I am going to do is I am going to rename my column. So I'll write column names US macro data, and now I'll will give the name of the columns which I want, and these names will replace the name it had earlier in the dataset. One second, this should be like this, and going on from here. All right, now I will just run this, and I will see to this again. So if you see, I have now my date, and then I have the same columns which I renamed here. All right, now the next thing is I am again going to extract GDP data and calculate GDP growth rates, which we did in the last one also using the XGX package. So I'll write the necessary command, and Now I will run this one also. We are multiplying by 400 because this is based on quarter. So yeah, I have my data set now for GDP growth. So this is more or less similar to what we did in our first video, except the library forecast which we installed in this video. Next, what I'm going to do is I'm going to subset this data set, and now we will start with the GDP growth. So in order to subset this data set, I will write GDP growth dot rate. This is basically the name of the new subset data set which I'm giving, and I'll write GDP growth 1963 to 2011. I'll just do one thing. I'll add here sub also, so that we remember always that this is subset. Okay, I'll run this. Now I will have one more, and this is what exactly we have got, the subset of the data set. Next, what I am going to do is I am going to see what exactly the length of this data set. So I'll write size, and I'll say length GDP growth rate underscore sub. Yeah, this one, the name, and I'll just run this. So if we see, we have 196L. Next, what we are going to do is we are going to lag for the last quarter of 2011 also. So we are going to miss those observations. So every time when you have to predict a value for a variable on time series, you miss the first quarter of the subset data set from where you are starting, and last quarter of the subset data set where your data set is actually ending. So now I will say GDP growth dot rate lags as dot numeric GDP growth rate sub, and now here I will write size. So I will run this, and now I have missed on the last observation of the data set also. Now what we are going to do is we are going to estimate the model. So I'll say model underscore 1, that is the name of the model, and I'll just write the OLS regression command, and now I'm going to give the name of the data set we are going to measure over GDP growth dot rate legs. So if you see here, what I have did earlier was I got my subset data set, and then I just level it. So we miss the first observation of the starting of the data set, and I am going to regress it on the data set which does not has the last quarter observation for us. To understand here, what we had did is I have just missed the first observation, that is in the my variable GDP growth rate underscore level, that is my dependent variable, and then I am actually regressing it on my GDP growth rate lags, which actually means the fourth quarter observation. So I'll just run this now, and I have my results. So I just do show you the results also. So if you see here, I have the intercept value, and then I have the GDP growth rate lags also. So this was the value we were talking about. I'll just do one thing. I guess the robust summary of the regression coefficient, so we can be sure that this is how exactly it is done. So I'll just run that command, which is cough test, and then R mode vcoff, and then we'll write vcoff hc and type hc1. So yes, So next I'm going to run this cough test equation to get the robust coefficient, and now I have the value for my regression coefficients. If you see here, I have my t value greater than 2, so I can say this is significantly different from 0. And if I just go back to what we had in our open board, here I have my beta naught and beta 1, and these value are these. So I have my beta naught and I have my beta 1. Beta 1 would be GDP growth rate lags. Just an important thing is that we have missed the value for the first quarter and the last quarter when I created my growth rate level and my growth rate lags. So now I have my beta naught and beta 1, and if I have to write down this back to the equation we were working on, then I will say this is 2.01 and this is 0.341. Here I will write GDP GR T minus 1, and this one is R, and here I will write GDP GR for the period T predicted value. So that is how exactly you create the autoregressive model equation. Now there is more theory which I want to show you before we move to forecasting the value of GDP. So just suppose I have autoregressive model 1. So in this case, what exactly happened is my dependent variable is calculated based on the value we had for it in period t plus 1 and t. So I'll just put this like this. So my value for the dependent variable is calculated for period t plus 1 based on what value it had in period t, and this will have my dependent variable also in period t. So in this case, we will have data up to period t, and after that we will be going to calculate. My forecast error in this case will be yt plus 1 minus y hat, whatever I got from my predicted value, this. So I can say this is my forecast error. Okay. Another thing you need to remember here is these forecast values are neither the values which OLS has predicted for us, because it is the difference between the predicted value and the actual value, and neither this is OLS residuals, because when we have OLS residuals, we do not make forecast for the next period. We actually find out the predicted value and then minus them from the actual value. But here we are actually predicting the value for the next quarter and then finding out what kind of forecast error we came across. So that is something which was not given to us earlier. So we did not have the actual value in this case. While when we run OLS and we have residuals, we have the actual value also with us and we find out the difference. Okay. So just to make this more clarified, forecast and forecast errors are basically your out of sample values. And when I talk about predicted value and OLS residual, they are in sample values. So basically they are coming from the sample we already had. But when we talk about forecast, they are coming out of sample because we did not have those actual values with us when we predicted the future. Okay. Now, another thing to note over here is when we have these forecasts, we will also have some error. So in this case, we will have your root mean squared forecast error. So I can write root mean squared forecast error. This kind of error generally comes when we actually predicted the future in a not very clarified way. So if I write down the formula for this root mean squared forecast error, it will be your square root and your expected value of yt plus 1 minus the actual value you predicted for your t plus 1 given that value we had t, and we have a square of this. So this is what basically your root mean square error stands for, and this root mean squared forecast error actually tends to your standard error of regression when we have a large sample size. So in this case what happened is I can write your root mean squared forecast error approximately equals to variance of your residuals like this. Okay, so we will move to R back. So I'll just hide my open board and we are back in R. Let's start working on forecasting now. Alright, so now to work on forecasting, what we are going to do is we are going to create a new data set. So I'll just say new data set, and this is the name of the data set which I'm giving. Then I will just mention data frame and what exactly my growth rate lags were. So I'll just say growth dot rate underscore lags, and this should be my GDP growth rate. Next what I'm going to do is I'm going to write GDP growth rate levels. So I'll just say growth rate level, and here I will say my size was reduced by 1 quarter data. So I'll just run this, and now I will make a forecast. So I will say forecast the value for 2012 quarter 1. So I'll say forecast using model 1 for my new data set, and this should give me point forecast as well as my 80% and 90% forecast interval. So I'll just run this. Okay, it should be data set. I'll just run this again, and I have my point forecast now. Also I have my low and high level for 80 and 95% forecast intervals. So either the value will lie here or here with 80% and 90% of forecast intervals confidence, and point forecast is 3.62. Now we will check for forecast error. So in order to check for the forecast error, first of all let's see what was the actual dataset value. So I'll just write GDP growth, which was my initial dataset name, and I'll say for 2012 what was the value for my quarter 1. So I'll just write this and we will run this, and okay, it should be 2012. Yeah, I'll just run this, and it says the value should have been 3.64 while what we got from the forecast is 3.62. Alright, so next what I'm going to do is I'm going to find out the forecast error. So I'll say forecast using model 1 for my new data set, and here I'm going to say that this should be the mean minus the actual GDP growth which was coming. So I'll just copy this actual growth formula and I will find out the forecast error. So I have a quite a low forecast error, that is 0.01 in this case. Now I will find out the R square. So that will be the proportion of variation coming in my GDP growth rate lagged by my GDP growth rate variable also. So I'll just say summary model 1, and then I'll ask for my R square. So this should close here only, and now I will just run this. So my R square, so basically this is saying that the 11% of the variation coming in GDP growth rate was explained through the past GDP growth rate variable. Okay, and the last thing which I would like to see is the average distance between the observed value from the regression line. So in this case I am going to find out the SER. So I will just say summary, and in summary I am going to write model 1, and here I am going to write dollar sigma. So I have my standard error of regression here, which is 3.20. All right. So what we did all today, just to summarize that, we actually went through the GDP growth rate data, and we forecasted the GDP growth rate for the next quarter using the past values, and then we check how exactly the forecast has been using the forecast error also, and then we summarize this with standard error of regression. All right. So yeah, I think that is all for this video. I will see you in the next one. Thank you.